Hello class, welcome to Algebra Concepts Lesson 8.1, which is all about multiplication properties of exponents. By the end of this lesson, you should be able to apply the multiplication properties of exponents to simplify expressions. So let's talk about our first key concept. It's something called product of powers. And so here you will see we have an example kind of drawn out in multiple colors to help you really visualize this. So whenever we have something to the second power, like 2 to the second means that we have two twos, right? There are two factors of 2. And then here, this tells us there are 3 factors of 2. So 1, 2, 3. Okay, so this is represented by the green. This is represented by that blue. And so what we're learning is kind of like a shortcut on if I were to give you 2 to the second times 2 to the third, like what's a faster way of figuring out what that is? And so instead of figuring out what's 2 to the second, what's 2 to the third, and then multiplying them together, instead what you can do is you can see, okay, I have 2 factors here, 3 factors here, so that's a total of 5. That means that this is 2 to the 5th power, and then you can just plug that into your calculator, because it's easier to just say 2 plus 3 and then say 2 to that number rather than saying 2 to the second times 2 to the third. Okay, so that's kind of an example of product of powers. Over here is another example. We have 4 to the 5th times 4 to the second. So this first one, the green one, we have 5 4s, right? 4 times 4 times 4 times 4 times 4. And then the second factor is 2. So 4 to the second, 4 times 4. So you can see that I have a total of 7 factors. So it would be faster to just write 4 to the 7th and then figure out what that number is. So product of powers is where you add your exponents together, and that becomes your new exponent. Sometimes you're going to be able to actually figure out what that number is. Sometimes it's going to end up being like a variable to an exponent, and that's fine too. So you can see some examples down here. If I have b to the second times b to the fourth, that becomes b to the sixth. Okay, so this page, really helpful. I recommend making sure it's in your notes. And let's move on to our first example, where we are simplifying these expressions. So you can see I have n and I have n. And I forgot to say on the last page, this only works if your variables are the same. So you can see we have if your base numbers are the same. So I have n and I have n. So they match. That's perfect. I can write n. And then what's 2 plus 5? That's 7. So that would be my final answer, and I'd be all done. Ooh, I'm going to try writing that one more time, so that way you can still see the answer. There we go. So I have n to the 7th. Okay? Pretty straightforward. The second one more step. This time we have regular numbers in front of our variables. So all you have to do is multiply those like normal, because we're multiplying here. There's no symbol written between. So 3 times 4 is just 12. But then you do the same process here. I have a c and a c. So it is c to the, what's 4 plus 8? That would be 12. So 12, c to the 12 would be my final answer for simplifying this expression. Let's try one more. So now I have my regular numbers. I have a 7 times a negative 2. Don't read this as 7 minus 2. Sometimes students do that. It's multiplication always between parentheses. So I have 7 times a negative 2 is negative 14. And then I have x, and then I have x to the 4th. Now, some students will say that this is x to the 4th because they see a 4 and there's nothing written here. But this is an invisible 1. Make sure that you don't forget about that invisible 1. That can be a really tricky thing to work with. But if there's a variable written there and there's no exponent, it's always a 1. Okay, so I have 1 plus 4, which is 5. And then I'm going to check my y's. I have y, and I have 2 here, 3 here. That's 5. Okay, and they aren't always going to match. Like, I noticed I had a 12 here, and then here I have 2 5s. You're not always going to have something that matches, and that's okay. Okay, so now I want you to look at this expression, and I want you to figure out which of these answers would be the simplest form of this expression. Good luck. All right, hopefully you said letter D, which was 2 times 3 is negative 6, and then we have n, 3 plus 5 is 8, so negative 6, n to the 8th. If you have questions about that, please be sure to ask for some help. I'm happy to help you. Let's move on to example 2. So example 2, we're going to just practice converting from standard form to scientific notation because it's probably been a while since you've worked with scientific notation. So remember, scientific notation is the kind of shortcut way of writing really, really big numbers or really, really small numbers. And it's always going to be a number times 10 to the, and then we're going to have an exponent. Okay, now there are some rules about this number. Okay, so this number here has to be between 1 and 10. Okay, so you need something between 1 and 10 for this number, and then this exponent tells you how many spaces you moved the decimal point. Okay, so that's how many spaces the decimal moved. Okay, so if I look at this first number, you can see I don't have a decimal written anywhere. In this one, it would be after the number, right? Because if we don't have anything after the decimal, we don't write a decimal. So my decimal is at the end. And in order to get the number to be between 1 and 10, I need my decimal to be all the way up here. So that way it's 3.1. So I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I moved it 10 spaces. So I'd say 3.102. You go until your last non-zero digit times 10 to the, I said I moved it 10 times. Okay? So when you're going from, when the decimal goes to the left, so when the decimal moves to the left to convert to scientific notation, it's a positive exponent. Okay? And then if we look at this next one, you can see my decimal is over here, and then my regular number's over here. I'm going to move it 1, 2, 3, 4, 5 times to get it, so that way it's a 3.13. That's a number between 1 and 10. And I'm going to say times 10 to that. I forgot what number I said. 1, 2, 3, 4, 5. 5, but this time when your decimal, oops, I wrote a B, decimal goes to the right, it is a negative exponent. So then you'd say negative 5. Okay? So that's a little recap on scientific notation. I would recommend you write something like this down here, maybe add a few details that help you, and then maybe just write a couple of examples like this on your note card. All right, so now what I want you to do is I want you to convert this number right here from standard form to scientific notation. Good luck. All right, for this problem, hopefully you ended up with 7.193 times 10 to the 7th. If you have questions about that, please be sure to reach out for some help. But all I did was I counted, here's my decimal, and I counted 1, 2, 3, 4, 5, 6, 7. So that way my number was between 1 and 10. And then since my decimal moved to the left, it is a positive 7. Okay, now let's move on to product of powers and scientific notation. So we have the fastest recorded star in the Milky Way galaxy is US 708, which travels 2,700,000 miles per hour. How far does US 708 travel in 1 year? We want to write our answer in scientific notation and then round to the nearest tenth. Okay, so in order to do that, we have 2,700,000 miles times how many hours in a year? 8,760. So if I multiply that really big number, I'm going to get, let's see, I'm typing it into my calculator. I'm going to get 2.23652, and I actually am using a calculator that's being a little finicky. I'm going to redo this. It is 2, 3, 6, 5, 2. 1, 2, 3, 1, 2, 3. Okay, so it is 23,652,000,000 miles in 1 year. But it's kind of a pain to write all of those zeros and keep track of where commas go and stuff. So we do a faster way. What we do is we convert it to the scientific notation. So we'd say 2 point, and then write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so times 10 to the 10th, and then we're also told to round to the nearest 10th. So we're going to do 2 point, and then instead of 3, I'm going to do 4. However, I will tell you, I would accept 2.3652 times 10 to the 10th as well. Okay, so either of these answers, in my opinion, are fine. The directions did specifically ask for the 10th, so this is what the question is looking for, but this is also correct, and I'm fine with that. All right, so all I did, I took the speed, multiplied by the number of hours in a year, took the really big number, and I converted it to scientific notation. Okay, so that is it for that kind of problem. You'll have a couple of those on your homework. And now let's move on to our next concept. It's something called power of a power. Okay, so now you'll see that my base, that 3, the big number, it only appears once. And then I have an exponent, a parentheses, and then another exponent. Anytime you have a situation like that, it's telling you that I have 3 of these. So I have a 3 to the 4th, a 3 to the 4th, and a 3 to the 4th. Okay? So now it's written out like what we kind of did last time, where we would just add each of them, right? So 4 plus 4 plus 4. And then we would get 12. Perfect. However, I know you guys like shortcuts. And so instead of like rewriting it 3 different ways and then adding up all of the exponents like that, what's faster than addition? Usually multiplication. And so whenever you have a situation like this where it is a power to a power, right? There's no like big number in between it. And what I mean by big number is exponents are usually written like a little smaller. It's a little hard to tell in this book, but like this is my big number. These are my little numbers. They're my exponents, okay? So if I were just to do 4 times 3, I would get that 12. Okay, and then same idea over here. I have r squared to the 5th. So I have r squared times r squared times r squared times r squared times r squared. Say that 5 times fast. I couldn't. And then you're going to just say, okay, 2 plus 2 plus 2 plus 2 plus 2. That's 10. Or I could have saved myself a lot of trouble and just said, what's 2 times 5? It's 10. Boom, done. Cut out all these middle steps. Okay, so when you have power to power, you multiply. Well, let's try a few. So here we want to simplify, and you can see that we have lots of things inside this parentheses. So you actually kind of use the distribution property too. So this right now is a 3 to the 1st. So I'm going to say 1 times 5. That's 5. Okay, so anytime you have a whole number without an exponent, you're going to assume it's 1, just like with the variable. And then we're going to say x, and then 5 times 5 is 25. And then I have 5 times 2, so y to the 10th. Okay, and then we're almost done. Sometimes your book will tell you it's okay to stop right there. Sometimes your book will tell you that you need to simplify further. And so the way that we would do that is we would say, let's see, 3 times 3 times 3 times 3 times 3, or 3 to the 5th. We would simplify this part because it can be simplified. That is 243. And then I'd say x to the 25th and y to the 10th. And since we don't know what x and y are, that's actually as far as I can go. All right, so hopefully you see the difference there. And then over here, let's try another one. So I have negative 5 squared. So that's like saying this. Anytime you have a negative that you are raising to a power, I want you to make sure when you put it into your calculator, you put parentheses around it. If you don't put parentheses around that, anytime you have an even number here, you're going to get the wrong answer in your calculator. And we can talk more about that one-on-one outside of this video. I'm happy to show you and explain, but we're going to keep moving on for this video. And then this is a to the first, so 2 times 1, that would be a to the second. And then 2 times 4, that would be b to the 8th. All right, so negative 5 squared, if I type that into a calculator just like that, that is a positive 25. And then a squared, b to the 8th. And then I'm all done. Perfect. Okay, that's as far as you have to go. So now I want you to try simplifying this expression. Good luck. All right, for your answer, hopefully you got negative 32, a to the 50th, b to the 20th. If you didn't, please be sure to reach out for some help. I'm happy to help you. We're going to move on just to our last example, and we're going to do a word problem. I know this is not your guys' favorite thing, but I promise you this word problem is something that looks scarier than it is. Okay, so we have Sir Terry Frost's Orchard Tambourine. B is a painting on a square canvas that consists of 5 rows and columns of smaller squares, each of which contains a circle. The painting to the right is of a similar form. Okay, so this picture right here is similar to this drawing that this painting that they've talked about. That's all the first sentence is saying. All right. Then, if the side of each smaller square is x inches, you can see it labeled right there, and the side of the whole canvas is s inches, then what is the area of the painting in terms of x? All right, so how do we find area of a square? Area of a square is just the side times the side, right? Oops, that shouldn't be a 5. Area of a square would be the side times the side, right? Side times side, or that would be side squared. All right, but we're not saying that it's side. We want it in terms of x. So I have 1x, 2x, 3x, 4x, 5x. So 5x is one of the sides. And 1, 2, 3, 4, 5. So it's, again, 5x because it's a square. And we're going to multiply those together. Or you could just say 5x squared. And then 5 squared is 25. And then x, 1 times 2 is 2. So the area in terms of x would just be 25x squared. And hopefully you understand that this is just the side length, and this is just the side length. It's 5x. Okay, that's all it is. And then I'm simplifying it. Okay, so hopefully this lesson doesn't seem too bad. I know at times it can look overwhelming with all of the exponents. So if that's you, don't freak out. That's pretty normal. But just be sure to ask lots of questions. I'm happy to help you. Again, I went into teaching because I love helping you guys. So feel free to ask questions. And I hope you guys all have a fantastic day.